Hello everyone, welcome back to Scalar Academy YouTube channel. Myself Vamsi. In this particular tutorial, we will be looking into the another article from the interview bit. Okay, what is this article all about? So often I used to get a lot of questions from my juniors regarding the product-based company interviews. Not even product-based companies interviews. It's about every company interviews. Okay, so the question was, apart from coding, what are the other areas they will be asking questions from? So I used to say DBMS, OS, and computer networks. So yes, so these are the very important things. So that will be focused in an interview apart from coding as well. So in this particular tutorial, we will be learning one such topic like subject named database management system. So what is database management system and what kind of questions that you can expect in an interview? Okay, so now in the next 1 hour, 1.5 hour, what are we going to cover? So we will be starting right from the what is it data, and then database, then DBMS, and how the data has been stored in a different manners, and where that database has been placed, and how to interact with the database, and how to access the database data from the databases, and what are the ways to access the data, and how to store such a huge data in one singular database. Will it be over, like we will be discussing all the pros and cons of storing data in the database, and what are the other alternatives that are being we will be having. And also we will be learning about normalization, two-tier architecture of a database, three-tier architecture of a database, and what are different types of database structures. Okay, so it will be easy to code and it will be easy to represent, like store, but how to communicate with others? Okay, how to, like, it's not like, oh okay, tell me about how did you store your data in this particular database. It's easy to show your database like code. So this is how I have written the code, and this is how I will be storing my data. So here comes the picture called entity relationship diagram. Okay, so that is the actual thing. So we'll be asked in a system designing rounds. Okay, if your interviewer is focusing more on to the low level designing. Okay, so I highly recommend you guys to watch this video till the end. Okay, so that you will get a bigger picture and better picture on what we are going to do in next 2 hours, and how to answer such a questions if you are in an interview. So before moving on to the actual video, I highly recommend you guys to please do subscribe to this channel. Please hit that like button up, and please let us know in the comment section how did you feel about this particular video. So let's discuss the very first question. So the question stated was, what is mean by DBMS and what is its utility? Explain RDBMS with examples. So they are asking us, so define what is DBMS and what is its necessity, like what is the need of DBMS and RDBMS. So RDBMS is one type of DBMS, okay, and they are asking us what is a DBMS, sorry, RDBMS, and explain it with some example. Okay, so let's try to understand what is DBMS first. DBMS. So let's try to decode this whole word. Okay, so a database management system. Okay, and again we'll talk about this first. So even in this we'll talk about this data. So what is a data? What is a data? So can I say that a raw input which is needed in the future, with that aim we will be preserving that. Okay, like what I'm trying to say was, so the data is something which you felt, okay, which is a very needed one. It might helpful in our future, so that if you felt that is needed and helpful in the future, then you must need to store that. right? Preserve that data. So then it is called as a data. Now what is a database? Now it's a, you can say that, a group of interrelated data. What is this interrelated data? So let's say um, let's say we are in a college. In college there will be around 5,000 to 10,000 students, right? 5,000 to 10,000 students. Now I need to keep them, like I need to keep all the students data forever, like at least for next 4 years. If I joined in my first year, I need to preserve that data for the next 4 years. So what will college do? So they will store all the details of CSC people in some place, in some table, let's say, like in some place. Just assume that it's a block, okay? CSC, and then ECE, then triple E, and even they do all this storing in some other folder. Let's say 2070 to 2021. So 2017 to 2021 is a, you can consider as a folder, and again in that folder we will be having other folders like CSC, ECE, triple E, and in that CSC folder we will be storing our data. So here all the CSC data has been stored somewhere. So can I say that this is an related data? So that is called a database. So this entire thing now is called as a database. Done. Now we'll move to the next thing called management system. So basically let's say I have stored all the data of first year students. Now after moving them to the second year, so I need to update the courses which they have enrolled, or let's say a few students left the college. Okay, few students left the college, so I need to update the DB, or I need to update my so delete few students, delete few students, or so there were some people who joins in the second year, right? So I need to insert them, insert the students. So can I say that all these were few operations that I need to perform on database? So just imagine, okay, just imagine like you will be having some kind of interface, okay, you will be having some kind of interface, and you will be having your database here. This is your database, and this is your interface, which helps you to perform all these kind of operations easily. Okay, then this is called as a management system, and with the combination of this mission is called as a DBMS. Now you got the what is DBMS, right? So database management system. So you will be having database, okay, and also you will be provided one interface, which is we are calling here it as a language, so that you can easily update your tons of data in a single go. Either it can be delete, insert, update kind of stuff, okay? So that is what DBMS means for. So now I guess we have answered the very first question. Now explain RDBMS with example. Now what is this RDBMS? So we know what is DBMS. We know what is DBMS. So in DBMS we have different types, like types in the sense how we are storing our data, that's it. Okay, so one of the way is RDBMS, so which is called as a relational database management system. So a relational means storing the data in the form of tables. So what does it mean by tables? So let's say I have this kind of one table. So generally for every table we will be having some uh, rows and columns, right? Rows and columns. So all these were rows. Row 1, row 2, and these are all columns. Column 1, column 2, column 3, column 4, column 5. Now what does this column states for? So the column states attributes or properties, and columns are like rows are the data which we wanted to store, So let's take one example and then I will try to explain it with you. So earlier we have talked about college data, right? So now let's say we are storing some student details. So if I wanted to store the student details, what are all the details which I am going to store? So can I say that I have to store the student ID, which in terms called as a roll number, and I need to store the name, mail ID, and branch, and like CGPA, so etc., mobile number. So these are all the common properties of every student. Okay, common properties. So these are called as attributes as well. Attributes. Okay, attributes. Now what is a row? So row means each student data. Each student data. Okay, we'll draw one table here. So we'll be taking only few columns. So roll number, name, and a branch. Okay, now this is our table. Yeah, this is our table. Now I will be storing the very first student. Let's say roll number is 100, name is XYZ, branch is CSC. Now again I need to store another student, which is roll number is 101, name is ABC, branch is ECE. Then goes on. Okay, so this is, can I say that this is called as a one student data, student one data. This is called another student. So all these were rows, and also these can be called as a tuples as well. Tuples. So these were columns or referred as attributes. So this is what, if we store our data in this particular format, this is called as an RDBMS. Okay, relational DB. So this is called relational DB, and RDBMS means it's an language. So it provides an interface called, it might be MySQL, SQL, MS SQL. Okay, so yeah, these are all the very famous RDBMS languages. Now you can use any of these things and you can interact with the DB. You can perform some operations on the DB, whatever you want. Okay, so there were some commands, so known as SQL commands, MySQL commands. So by using that you can interact with your DB. Okay, so we'll talk about those things as well in the later part. Now that is what we have seen for this thing, this particular example. Okay, so they have taken one website. Okay, they have taken one website. So yeah, so here there is a website front end, and you just assume you have requested some data. Okay, like you have an interface like this. Look, where you will be giving the student roll number like 100 or 200 something, then submitting. Okay, so after submitting, you will be getting all the student all the details of that particular student who is bearing that roll number. Okay, now how it should go. So you have a website, then it will make a call to the DB, which is an fetch. Okay, fetch data. Then it will go to the database. So here you can find the student record. Okay, so that is been returning here, then it will return here. Okay, this is how the flow, the control should go here. Okay, I hope you got some enough idea on what is what is data, what is database, what is DBMS, what is RDBMS, and how does it work. Okay, and what kind of data we store there and how we store there. Okay, now the second question is, what is mean by database? I guess we have answered this question earlier, so let's go try to walk through this definition. That's it. So a database is an organized, consistent and logical collection of data that can be easily updated, accessed, manageable. Okay, so earlier we have discussed a formal, like informal definition. Now you can see the formal definition. So if you are in an interview, you should something first tell something like this. Okay, then you can pick up one example, then you can explain it in a better way. Okay, so if you are in an interview, your interviewer expects you to tell the concept rather than a formal definition, but don't directly jump into the a real world example as well, because uh, it it won't show your communication skills. Okay, so first tell this. Okay, then explain it with an real world example. Database mostly contains a set of tables or objects. Okay, so that is what it is showing, like whatever we have discussed. So they have taken RDBMS here. Okay, that's why they are representing as a table. Okay, so just go through that, you will get it. Now the next question, mention the issues with traditional file based systems that make DBMS a better choice. Okay, so they are asking us actually why we need databases. Okay, why we need databases? We have file systems, right? Like we are storing all our data here. Then what is a need? So the need was they are given three examples. I think that should be sufficient if you are in an interview. Okay, now the very first thing is searching. They are referring it as a indexing as well. So searching means what does this searching? So let's assume you are in a file system environment, like where you are storing all the details in your computer manually, like folders. Now I wanted to search for one particular student whose roll number is 201, right? 2001. Now imagine, okay, there were 10,000 students in a college. 10,000 students in a college, and you need to search the student roll number where it is being called referred as in 2001. Now how much time it will take, how much effort you need to put here. So in worst case, if that 2001 is being stored in the very last, okay, then you need to cross check 1,000 files. Okay, is this what I'm looking, so if it eventually makes your job little hectic and complex, right? So that is the one of the major issue with the file system. So this issue has been overridden by the DBMSs. Okay, so they will be providing an interface, okay, like language. Then you can simply write a query. Okay, like give me the 2001 ID student, then it will give you. That's it, it's as simple as that. Okay, so all you need to know is just one query, that's it. Okay, it will get your job done in within fraction of seconds. Okay, so you might be thinking 10K is reasonable search, but nowadays people are searching in, well, like the data has been gone to PBs. Okay, like 100 TBs. Okay, it's you, up to your imagination. Okay, now what you can think of in a bigger way. Now the second solution that we were considering is concurrency control. So if you don't know what is concurrency control, it's okay, but as of now I will be stating this in a very simpler manner. So let's say you can consider it as a multitasking. Okay, so lack of concurrency control, which leads to one operation locking the entire page. So they are simply stating that, let's say if you are searching for a 2001 student, okay, then you are blocked by this particular activity only. You are not able to do other activities, like you need to delete some uh, student details. Okay, delete student details. Now what you need to do, first you need to complete this, then you need to come back to this, right? Which is like, if this particular task is taking 30 minutes, then you, to complete this particular task, you need to wait for 30 minutes, right? So this is one of the major problem in file system. It is overcoming by DBMS. Okay, so where DBMS supports concurrency control, where you can do a multiple task at a time. Now integrity check, data isolation, atomicity, security, etc. So these are some of the advantages over the file based systems in DBMSs. Okay, so let's move on to the fourth question, which is an explain a few advantages of DBMS. I think like we have covered two advantages in the earlier question only, but yeah. So yeah, these are all the few advantages. We'll talk about each of them in detail. First one is data sharing. We'll talk about a scenario a 100 years back, sorry, a 40 to 50 years back. Okay, let's say earlier they used to store all the details in one mainframe system. Okay, mainframe system. So where there is nothing called a DBMS earlier. Now they have this. So this is their system, and they have stored all the data here. Now this is employee 1 and this is employee 2. Now employee 2 needs the data. Employee 2 needs this particular data. Now what happens? You need to copy these things. You know that it won't happen, because either he has to go and use this particular system. That's it. That is the only possible way there. So which is not possible, right? Every employee needs an own problem, like one work. So what is a kind of problem that way? So they decided to terminate this particular problem. So how did? So just imagine the case where this data has been in some central storage. Okay, central storage, one room kind of stuff. Now all the systems were being linked to this. Okay, all the systems were being linked to this. Now everyone, like every employee, can access the data with some credentials. Okay, that's it. That's as simple as that. So this is one of the biggest advantage here. So you will be storing all your data in this database, like cloud or something. Okay, you will be putting it somewhere, and you will be giving connections to the all the employees. They can access it, right? So you can imagine, like whatever the data you are using nowadays, like whatever the app, whatever the website, whatever the YouTube video. Okay, so do you store all the YouTube videos in your mobile? No, it is coming from somewhere. Okay, they are storing it in some big data centers, and we are getting that. That's it. Okay, and integrity constraints. So the existence of such constraints allow storing of data in an organized and refined manner. So basically these integrity constraints helps us to uh, access the data uniquely. Okay, and which helps to reduce some problems like anomalies. Okay, we'll talk about them later. Now third one, controlling redundancy in the databases. So redundancy means a duplicates. What is this duplicate stands for? Let's say like file based scenarios. So you will be storing all the students details. Unfortunately you yeah, you like just imagine, okay, you are copy pasting everything. Okay, so you have copied and pasted for the multiple times. So now all your files, so for each student, let's say 2001, it will be storing 3 copies of it, and 2002 3 copies. So now just imagine if you have 1,000 students, then each student copy is been storing for the 3 times, then it could have been gone to 3,000 copies. Now you are wasting a lot of storage here, right? And it will make your system little slow on accessing and searching as well. So to overcome these problems, our databases usually don't allow redundancy. Okay, it will try to reduce the redundancy as much as possible. Okay, so it will store only the unique values, so it will help you to search it easily, and it will provide an way so that you can maximize your utilization of databases. Now data independence. So here, let's say, now in this case we'll take this particular file system example. So you have identified that, okay, for every student you will be having 2 copies. Okay, for every student you will be having 2 copies, or uh, you will be storing the things in 2 folders. Okay, 2001. Now you wish to delete one file. Okay, you wish to delete the student record. Now you will go to this folder and you will delete this. Okay, now you you thought this is the only folder where I am storing all the data. You forgot about these two, but after few years you find that I haven't deleted the data here, and which leads to the complexness, right? So to overcome that kind of problems, okay, to overcome that kind of problems, so your DBMS provides an way to, okay, so to link all the data, and if you delete somewhere, okay, if you delete that particular ID or file in some table, it will delete all the existing or the same files in some tables as well. Okay, so that it will, you can use the things in an efficient manner. Now provides backup and recovery facility. So yeah, so just imagine, okay, you have stored all the data in some folder, and you mistakenly deleted that particular folder. Now what happens? You can't retrieve that data now. So with that thing, database DBMSs provide an way to back up your files, and you can recover them even after deleting them as well, okay, by mistakenly. And data security. So usually, okay, nowadays we will be having lot of security like passwords, file folder passwords, file passwords and all. But back then that was not the scenario. And just imagine you will be saving all your bank details in one folder, and if I go and if I open that folder, then I can able to access all your bank details. Now what happens? bankrupt, right? So to overcome that kind of problems, DBMS has provided better security for your data. Okay, you can give personalized authentication, and you can keep track of whoever are using login using that particular authentication. Okay, so this is the advantages of DBMS. Okay, so let's see the next question. So explain different languages present in the DBMS. So following are various languages present in the DBMS. So languages in the sense like to interact with your DB. Okay, so here languages were some commands. Okay, commands. So in that languages we will be having four types. Okay, first one is DDL, data definition language. So which helps us to create a tables, create a DB. Okay, so it contains commands which are required to define the database. Okay, like create, so it will help us to either create tables or database. Okay, we have seen what is table, what is database, right? And we have alter, which helps us to alter the things, or okay, alter the things present in the either in the table, like table names, okay, column names, sizes and type, like that. And drop, a drop is used to drop the data present in the tables. And truncate as well. Okay, so there is a small difference between drop and truncate. We'll talk about them in later part. So rename, so rename is helps us to rename the tables and database names. Now the second one is data manipulation language. So it contains commands which are required to manipulate the data present inside the database. Okay, like we will be having a data, okay, and then we will be manipulating it, means either we are updating and we are inserting and we are deleting, and these are all the commands which are there for DML command. Okay, DML language. So select is used to retrieve the data. Okay, retrieve the data. And update is used to update the data present in the table. And insert is used to insert the data into the database or table. And delete is used to delete the tables, okay, or data. Now the third one is DCL. So data control language. It contains commands which are required to deal with the user permissions and controls of a database system. So basically we have talked earlier. So a database provides a better data security. So how does it work? So let's say we have a person, okay, and we want to, like, there is some table, okay, student table or student database, okay, and there are two people for in college, let's say principal or students. Okay, now what I need to do, I need not to allow the, okay, I need not to allow the access permission to the students, right? Because students are not able, like cannot access this student table. So only principal and support staff should be able to access this particular student database. Now just imagine another case, okay, where students are working in some project, okay, and they need some database access. So that we can access some database, like we can grant the permissions, and after some time, like whenever their work is done, we can revoke the permissions. So to grant and revoke, we will be using data control language commands. Okay, data control language commands. Now the last one, transaction control languages. So here transactions means like you will be performing a lot of sequence of operations, right? Be it update, be it delete, be it inserting, okay, and we will be keeping track of all these things, okay, like whatever we have done so far. Okay, now we need to save them up. Okay, here commit means like whatever transactions you have made, be it inserting, update, you need to store them. Okay, you need to store them before you are leaving. That is what commit means. And rollback means, let's say you have unfortunately deleted few tables. Now you need to get back those things. So then you can use rollback. So save points helps us to save at the current point. Okay. And these are all the different languages provided by the DBMS to interact with your databases. Okay. Now the next question was, what is mean by ACID properties? So very important question. Okay, very important question. So it's a crime if you are not prepared ACID properties, and if you are attempting any product based company, so you are for sure you are going to screw up your interview, I guess. Okay, so what is mean by ACID properties in DBMS? So ACID stands for, ACID stands for atomicity, atomicity, consistency, isolation, and durability. So we'll talk about them each. Okay, each one. Now in simpler manner, they are saying that atomicity means all the changes to the data must be performed successfully or not at all. So we'll take one phone pay transaction or anything. So nowadays everyone using phone pay and all, right? So just imagine you started one payment. Okay, you started one payment to the one shopkeeper. Okay, started one payment to the shopkeeper. So now what is your aim? Either it has to go to the shopkeeper successfully, or it should not go. Okay, it should not debited amount and not credited. So in either of the cases, you don't have any problem, right? This is what an user wants. It's not like, so my amount got detected from my bank. Okay, amount got detected from my bank and it is not credited into the shopkeeper account. Then there is a problem. So a DBMS states that make sure that either of the things, okay, either it should be success and it should not happen at all. So this is the principle that it follows. Okay, it should not go, it should not start and it should not end in the middle. Okay, so that is what atomicity means. Okay, so if you have started, you need to finish that. Okay, there is no midway coming back. That is what it is saying that. And second one is consistency. So consistency means whatever the data, okay, so this property ensures that the data remains consistent before and after a transaction. So you will be let's say, so in a earlier example, so your current balance was 2000. Okay, and you have started a payment of 1000 rupees to the shopkeeper, to the shopkeeper the shopkeeper. Now after, okay, now just imagine the scenario as this is a success status. Okay, means your payment got successfully completed. So if you open the current balance now after payment, after, then it should reflect 1000 here, and in shopkeeper account it should be like balance plus 1000, right? If in any of the cases, for any of the reasons, if it fails to update like this, okay, then we can say that this is an inconsistency data. Okay, so if it is a something like this only, then we can say that it consistency. So whatever the data happened, like transaction happened, it has stored all the data over there, so we are good now. Okay, so the second principle must be, so after performing any operations, the data has to be keep on updating. That's it. It must be stored all the updated data only. Now the third one is isolation. So what is this isolation means? So you might be performing different or multiple transactions on the same side. Let's say so there is a shopkeeper and customer 1, customer 2, and customer 3. So everyone is doing phone pay transaction only. Okay, so you are sending 100 rupees and this customer 2 sending 50 rupees, customer 3 sending 200 rupees. So here if you are doing your transaction, you can't say stop it like, okay, hey customer 2, so sorry to interrupt, please be away, so let me complete my transaction. No, you should not tell like that. Okay, so whoever transferring amount to a shopkeeper, you should respect them and you should make sure that everything goes well. Okay, so it's support like this is how it works in the DBMS. Okay, so irrespective of any number of people are doing the same operations at the same time, okay, the data has to be stored or preserved all the time, and there should be no interruption occur to the other customers who are sharing at the same time. Okay, so that is an other principle or property of a DBMS. And the next one is durability. What is durability? So here let's say like in your current balance is 1,000 rupees. Okay, and all of a sudden your mobile got switched off. Okay, switched off. Now again you put some charging and you opened again. Okay, open your mobile again, and you have seen that there is a 900 balance in your account. So this should not be the case. So every time, like after every transaction, you need to like keep track of whatever happened so far. Okay, and everything has to be preserved for forever in the future. So here our data is like, so just imagine, okay, you have sent 200 rupees to someone, 200 rupees to someone, and still after 1,000, okay, so your correct from the 1,000 you have sent 200 to someone. So now your database should reflect 800. Instead of this 800, if it is still showing 1,000 rupees, then it is failing, right? So anyhow, like we are getting benefited, but this is failing, right? In case of missionaries. So that should not be the case. So the same state should reflect everywhere. So if you checked it in a phone pay, if you checked it in Google Pay, so all the same amount has to be shown. Okay, so in phone pay it is showing 800, in GPay it is showing 1,000 rupees. If I go to bank passbook it is showing 500 rupees. That should not be the case. Okay, after every transaction, either it has been failed or passed, it should save the previous state, and if it is successful it should show the current state. Okay, in all the possible ways that he or she can store. Okay, in case of different applications that nowadays we are using. Okay, that is what this durability means. Okay, now these ACID properties make sure that every transaction, like whatever operations you are performing, or everything are going pretty good. Okay, nothing is happening in between, and these are all the principles that every DBMS should follow and will follow as well. Okay, now let's move on to the next question. So the next question is, are null values in database the same as that blank space or zero? Good question. Good question. Like personally as a software developer, I see a lot of null values in the lot of databases. Okay, after seeing them, like if you feel that this is not the case, so I can't handle this, and what all these null values, so uh, then you might be in some wrong thing. Okay, you should be wondering how we need to handle that. Okay, what if there is no data but I need to put it on the UI part? Okay, so then you need to understand the context over there, like what kind of scenario that you are considering. So just imagine, okay, just imagine, you just imagine as a phone pay only, phone pay, and you need to print all the current balance. So if your current balance is null as of now, okay, null, so which means no data at all, no data. So which it doesn't mean that, it doesn't mean that 0 rupee in your current balance, right? So just imagine like where in your from to your database you have a null value, okay, and at the same time user has asked for current balance. Now since you have assumed that null balance as a zero, if you assume null balance as a zero, and for user you have shown 0 rupees in your current account, now user will straight away ping the client services like customer support, because in current balance he is thinking that he might have 25k, but you are showing 0 as current balance. Okay, so 0 means 0, null means not 0. Okay, null or blank space, whatever here. Okay, this is probably a very good example. I have personally faced seen this problem many times as a fintech company developer. So no, a null value is a very different from that of 0 or blank space as it represent as a value. Okay, so they are saying that null, no, null value is null value, 0 is something 0 only. Okay, so they have given one example here as well, but yeah, so whatever I have discussed from my experience is also good. So null values in number of courses taken by a student represents that its value is unknown, whereas 0 means in it means that student hasn't taken any courses. So here they have considering a scenario like table where they will be storing number of courses a student has been enrolled. Okay, so like just imagine you have a UI and you will be providing the roll number, and you will be having button like submit, and after submitting this after clicking on this particular button you will be getting all the course details where student has been enrolled, right, where student has been enrolled. Now if you got all the null values, like all the null like empty values, it doesn't mean that student hasn't enrolled in any courses. Okay, it means only that you will be like data is not available only. Okay, it doesn't mean that student does not enroll in any courses. If and only if you get 0, it means that student does not enter like enrolled in any courses. Okay, null not equal to 0, blank space not equal to 0. Okay, let's see another question. So question number 8, what is meant by data warehousing? So the process of collecting, extracting, transforming, and loading data from multiple sources and storing them into one database is known as a data warehouse. So they are saying that we will be getting data from the different sources. Okay, and from that different sources we are extracting the data what we wanted. Okay, and like let's say there is this YouTube, right? YouTube. So in YouTube everyone gets the uh, like customized ads, right? Customized ads or some advertisements, okay, posts and all. So you can mostly you have related to that, like, so if I went to Amazon, okay, if I go to Amazon and if I search for any TVs, okay, if I search for any TVs or laptops, and then if I go to YouTube I will get a advertisements or in between ads which are related to the either laptops or TVs. And even if I did the same in Google search, if I go and search for few MacBook prices, MacBook Air price, MacBook Pro prices, then if I come back to YouTube, again I can see the ads of YouTube with the prices tag. Now how this is working? So here the sources are very different, right? So here we are getting the data from apps, here we are getting the data from internet browsers, but we are using that particular, like we are combining all the data together and we are just suggesting the things, right? So this is what a data warehousing means. Okay, like you will be getting data from the different sources and storing in one place and processing it together, and again you will be using that same data for different purposes, not only for one purpose. Let's say like I got the data like Amazon data and Google search history, and I'm storing them in one place. Okay, I'm storing them in one place. Now this is being used for YouTube, and also in for Amazon also, like it will try to show all the things what I have searched previously on my screen only, right? For apps itself, and for Google, and for Play Store. Okay, if I go to Play Store and if I search for any shopping app, then I will get an all the shopping apps, right? All the like Flipkart, Amazon, Meesho, all the things. So how this is being happening? So you are getting data from different sources, and from that different sources you are processing it together, and they felt that you are looking for one MacBook Pro, and then they are keeping on advertising that MacBook Pro everywhere you go. Okay, if you go to YouTube you will see that, if you go to Google you will see that, if you go to Amazon website you will see that. Okay, so this is how a data warehousing works. Okay, let's move on to the next question. So explain different levels of data abstraction in a DBMS. Okay, so here what is a data abstraction first? So if you don't know what is data abstraction, so a data abstraction means, in simpler, in OOPS terminology, hiding the unnecessary complexity and showing only necessary parts. Okay, the best example would be the ATM. Okay, like we only care about like putting the card and entering the password and getting the money, but we really don't know how that is being processed in the backend, and how your request, like how your APN pin is getting validated and how your barcode is being scanning and all. We don't care about that. We only want money. We are getting that. That's it. Okay, this is what abstraction means. So they are asking us what is happening behind this particular data and what are the levels are there in the database transactions. Okay, so here I would like to point out, divide this whole part, okay, into the three parts. Okay, let's say this is part 1, part 2 and part 3. So 1, 2, 3. So just imagine, you can assume this part 3 as an like UI, where a user can access the data. Okay, like you can simply consider this as one website. Okay, consider this as a one website, and now what all you can do, so you can request the, like you can submit your roll number and you can get the results, right? That's it. Now that is what happens at the user screen. Okay, and then in the second level, this is for a developers. Okay, this is for a developers. Okay, this is for developers who are developing your website. Okay, so where they can directly interact with the DBs, okay, by using some commands. They can manipulate the data, they can retrieve the data, they can update the data. Okay, So this is what a developers can do at the level 2. Okay, level 2. And now this level 3 people, like where users cannot access this level 2 permissions. Okay, so level 3 is only like level 3 people can only access the level 3 thing, but level 2 people can access both level 3 and level 2. Okay, and there here comes the last level, which is a level 1. So in this particular level we will be providing only the details of how much data has been stored, okay, and how much memory has been used and who are all using that. It will be for organizing heads. Okay, organizing heads. Okay, like all the databases are being created. Okay, database creation and all. So here this is for developers and this is for clients, okay, who are using your end product. Now if you wanted to put it in a hierarchy, so this level people, level 1 people can access all the 3 levels, but level 3 people can access, sorry, level 2 people can access only 2 levels, first 2 levels, and level 1 people, level 3 people can access only level 1. Okay, so these are all the levels or abstraction layers available in the DBMS. Now they have named these levels as well. So this particular level 3 is called as a view level, where it can be accessed to the clients. Now level 2 is called as a logical level, where logical implementation and actual data storing happens. And level 1, where actual it is called as a physical layer. Okay, physical level or layer, whatever you call it as a. And this is where actual databases are being stored, and there will be some configuration details as well, which is not occurred for developers and users. So this is the abstraction that it is following, and these are all the levels of abstraction. Okay, layers as well. So this is about this question. Let's move on to the next question. What is mean by entity relationship? Explain the terms called entity, entity type, and entity set in a DBMS. So it is in two questions, okay, and 4 definitions, okay. So what is the first question is, what is ER model? So ER stands for entity relationship, entity relationship model. So we are, okay, like, so we are storing a lot of like we are having databases. In that particular databases we will be storing all our tables, and we will be linking, like we will be having some relationship between a few tables as well. So how we are going to represent them? So just like as a developers we can remember them, okay, but to understand, like to put it in a high level context, we need to represent them as a diagrams. So that particular diagram is called as a ER diagram. So if you can observe here, you can see, right? So we will be having a two entities. Okay, this student is one entity, college is one entity. And what is an entity? An entity is a real world object which has some existence. Okay, so student is one object, like entity, college is one entity. And what is the relationship between among these two tables? So entity is an table. Okay, so studying, so student studying in college, right? So there is some relationship. So every student will have a college, right? And in college students were there, obviously. So this is called as an entity. So entity is an table. So for every table we will be having an attributes. So attributes are also columns. So entity means referring to the only one particular object. Okay, a student, like only one person. Okay, an employee, one person. That's it. An entity type means grouping like similar kind of things, okay, onto the one thing. Let's say you can see, right? So every student, okay, here, so every student will be having the same attributes like student id, student name, student email id, mobile id. So every student will have the same kind of attributes. Then we can call them as entity type. Okay, an entity type is defined as a collection of entities that has the same attributes. Okay, so them, so like, so if I consider different students, so student 1 will have all this student id, name and all, and student 2 will also have the same name, college and all, and student 3 will also have the same. So after seeing these three students, I can say that id, name and branch is common for every student. Now I can refer them as a one like entity type. So these are student types. Okay, so it is something like data type in our programming language. Now the next question is entity set. Entity set. So an entity set can be defined as a set of all entities present in a specific entity type in database. For example, set of all students, employees, teachers, etc. So now whatever, like whoever having the same set of entity types, like here student 1, student 2, student 3 will have same entity types, right? Now I can group them all, and after grouping them all, I can say that these are all the students. Okay, whoever having this role number, name, whoever belongs to this particular college, I can say that all of them as a students. And whoever having employee id, employee name, and so works in some organization, I am calling them as employees, all employees, right? So this is how the difference between entity type and entity set. Okay, let's move on to the next question. So explain different types of relationship among the tables in a database. So which is an very important and like I won't say it's a frequently asked interview question, but it's good to have this knowledge while, because if you are asked to develop any OOD like object oriented design or LLD or low level design, so this is very important. You must have to point these things. Okay, you must have to tell the relationship between two different tables. Okay, in that case it is very important. Okay, so here we will be having three types of relationship. One is like four types basically. Yeah, so first one is one-to-one relationship. So what is this one-to-one relationship? So just imagine you have one table here and you have one table here, and in this particular table one row has some relationship between one row in the table 2. In that case we can say that it's an one-to-one relationship. Okay, and this one-to-many relationship means, let's say you have a table 1, okay, where one row from the table 1 refers to the multiple rows in the table 2. Now what happens? So this is called as an one-to-many relationship. Like you can watch out these examples, right? So that's why I'm not telling them. And the next one is many-to-many relationship. So many-to-many to relationship means, so from table 1, many rows, okay, many rows refers to the many rows in the table 2. Okay, then that is called as a many-to-many relationship. So the next one is self-referencing relationship. So self-referencing relationship means if you were rows, okay, in one table refers to the another rows within the same table, then that is called as an self-referencing relationship. Okay, and there is another thing as well, many to one. Okay, like many to one relationship means many columns, like many rows from the table 1 referring to the single row in the table 2, then that is called as a many to one relationship. I hope you got it. So now let's move on to the next question. So explain that difference between intention and extension in a database. Okay, so intention and extension. So basically, intention refers to the database schema. So yeah, intention are popularly known as a database schema. So if you don't know what is database schema, I will tell you. Okay, I will tell you what is database schema. Database schema. So if you consider a database where you will be storing all your student details, then whenever you you decided to create the database of students, you should be figure out what are all the attributes that you need to store, right? So it is a student ID, name, branch, email ID. So you will be creating this skeleton. Okay, so you are telling that for every student we will be having all of them, and whenever you are trying to insert data into the database, you must need to provide all these data. Okay, so that is this particular skeleton is called as a database schema. So a database schema is used to define the description of a database and is specified during the design of database, right? So when can you when you will you decide all these attributes? So whenever you have planned to create a database for student, right? So in the beginning of the storage as well, okay, while you decided to design, then you need to decide to store, then you need to design an ER diagram, and then you need to mention all of them in that particular diagram itself. Okay, that is called intention. And if you design it once, if you define the schema once, it cannot be modified later. Okay, I will tell you the reasons why we cannot modify that later, the later part. Now the extension. So extension on other hand is the measure of number of tuples present in the database at a given point of the time. So okay, we are done with schema. Now we started inserting our data. Okay, inserting our data. Okay, I have all the schema ready. Schema ready. Now I will start storing the data into the table, right? Now at some point, okay, after inserting some 10 rows, 10 student records, I wanted to figure out how many students tables that I have inserted so far. Okay, then I can figure out that I have inserted 10. Okay, which means it is called as an extension. Okay, so the extension of database is also referred as a snapshot of database, and its value keeps changing as when the tuples are created, updated, destroyed in a database. Like it's just an information or description about your database so far, like what are all the things happen and what are all how many data are present, that's it. Okay, let's discuss another question in the DBMS interview preparation. So explain the difference between a delete and truncate commands in a DBMS. So as we discussed during the languages in DBMS, we have talked about this delete and truncate, right? So now they are asking about the differences between the delete and truncate. So if you remember, I have told both are being used for deleting the data only, but it differs in something else. Okay, we'll talk about that in detail now. So a delete versus a truncate, so which is a very important question. Okay, very important question in interviews perspective. So basically this delete, okay, this delete will delete the rows. Okay, delete the rows, but with some condition. Okay, with condition, which means, let's say I have all the data of students. Okay, now I wanted to delete the student data uh, whose roll number is equal to 200. Now here I have a condition, whoever a student whoever having a roll number of 200, I need to delete that particular record itself. Okay, I need not to delete entire data. Okay, like all the student details. Now I have to delete only this 200 roll number student only. So here I have some condition, I will be deleting that particular row. Now after deleting that particular row, can I get that back? Yes, you can roll back. So if you remember, we have discussed about commit and rollback. So commit will help you to save the, like, preserve the changes, and rollback will help you to get your like deleted or eliminated things back. Okay, yes, you can roll back. Now coming to this truncate, so again it will delete the rows. Okay, it will delete the rows, but here with no condition. With no condition, it means that if you truncate one table, like it will truncate all the data, it means delete all the data present in a table. Okay, it won't even keep single row, single record of a student. It will delete all the data from the table. That's it, without any condition. Now my question, like, you might be wondering, can I get the data back? Yes, you can. Okay, you can roll back it, but it has some limitations in it, like few versions of MySQL databases doesn't support truncate rollback. Okay, only few things will support the truncate rollback. So if you do that, you might face the data loss as well. Data loss means like suppose if there are 1,000 records, then if you are trying to roll back, you might get 800, or your data might get corrupted as well. Okay, and which one is faster and which one is slow? So this one is slow little bit, and this is fast. Why? Here you will be having some conditions, you need to check, right? You need to traverse through all the data, you need to search for that particular condition, then only you need to delete. On top of that, you will be maintaining your logs as well. Logs means, like, what are you doing, what are the data you are deleting and all, because you need to roll back, right? So but here you don't need any conditions, you don't have any conditions, all you can do is just delete everything. Okay, so it is faster, and also it won't maintain logs as well. Okay, it won't maintain logs as well, means, like, as we discussed. So that is the reason why you were while trying to roll back, you might face a data loss issues. That is the difference between delete and truncate, which is very important question in an interview. Let's move on to the next question. So the next question is, what is a lock? Explain the major difference between a shared lock and exclusively lock during a transaction in a database. So which is very easy question, like in terms of all the transaction questions I hate. Okay, so it says that, like, shared lock. First we'll talk about shared lock. Okay, so what is a lock first? So basically you will be performing like, so let's say you have a DB, and this DB has access to many servers, right? Many servers, so many people can access this data. Now let's say I am performing some write operations here, like I'm trying to, let's say I have account balance as 100 rupees. Now I'm trying to delete, okay, I'm trying to withdraw 50 rupees. Okay, now at the same time, like let's say person, or let's say father, son and father, okay, son and here father. So they have joint account, okay, and son is staying in hostel, so he wants to withdraw all the money, and father is staying in some other city, he also would like to withdraw only. Now son assumes that he has seen fetched that particular current balance, and he has seen there is 100 rupees. Now he decided to withdraw 50 rupees, and at the same time dad also trying to withdraw the amount of 100 rupees. Now what happens? It will either fail, usually it will fail, but to handle such kind of situations we will be having these logs. Okay, so if one user entered into state, then we are locking him and we are not allowing other users to access the data. Okay, so this is how a lock mechanism works, and we'll now have two types: shared lock and exclusive lock. Okay, we'll talk about the shared lock now. So shared lock means for read operations. Okay, so let's say we have a account, joint account, where I have 10k in my account. Now my dad is also trying to like check the current balance, and me also trying to check the current balance. Now will there be any problem? No, right? There is no problem. It's just a simple read operation. We are not withdrawing the amount, means not writing the amount. Okay, so it's just a read operation. So you can allow as many users you want. Okay, in shared lock has been used for a read operation specifically. Okay, and you can allow as many users you want to access the same account or same database at the same time. Okay, this is about shared lock, and the next one is exclusively lock. Exclusive lock. Wait, sorry, exclusive lock. So in shared lock we are using that for read operation, but in exclusive lock it will use for write operation. So as we discussed the problem earlier, so write has to be only one person can perform a write operation. Means let's say if son is trying to withdraw the money, so it should not allow the father to withdraw at the same time, because it will lead to the inconsistent state. Okay, they might face a problem in the future. Now what I can do, so let's say I have a like account like or ATM now. So whenever someone has, like either whoever comes first, so try to withdraw the amount. Okay, withdraw the amount, then you need to lock that up. Okay, so someone is tried to withdraw, then you need to lock this particular account. Okay, until this person completed his transaction. So after completing the transaction, you should remove this lock and allow other persons to access the same account. Okay, then they won't see any problem, right? So because they are going one after one, they are not doing the operations on the same time. So after completing one particular task, data will get updated, and further can see that there is no balance. Okay, there is only 50 rupees. Okay, I can't withdraw 100 rupees. Okay, so this is how we can use this locking mechanism to avoid transaction failures and data inconsistency. Now the next question is, what is mean by normalization and denormalization? Okay, so and normalization is very important. Okay, very important topic for interviews. So we will be talking about different types of normal forms available and how to write them and how to create them as well. Okay, now just keep this in mind. Normalization is very important topic. So a normalization is a process of reducing the redundancy by organizing the data into multiple tables. So just imagine, okay, just imagine you have a very big table, okay, very big table where you will be storing all your data in single table. Okay, it's a single table. Okay, like where you will be storing all the let's say if you are Amazon thing. Okay, so this table is storing all your Amazon data, like customer details, order details, and payment details, all you are storing in this particular single table only. So now what happens? What is the problem? So it keeps on increasing in an exponential manner. So at some point of the state, it will be overburden for that particular table as well to maintain such a huge database. At the same time, you might be taking different uh, different duplicates in it. Like say, so I will be storing customer details at some time, let's say 100, and the same time this particular student customer ID has performed some payment failure, so you will be storing that. So payment success, you will be storing that. So he has ordered something, you will be storing that. So it keeps on storing, expanding, right? So you will be having different duplicate data. So to avoid these kind of problems, we have come up with a solution called normalization. Okay, so what is a normalization? So a normalization divide your big one table to the different small tables, so that the chances of uh, like having a duplicate data will be less, and you will be like you are accessing the data as well from the database will be little faster when compared to the single database. Okay, single table. Okay, that is what, and it is also easy to maintain as well, right? So you like if like you are avoiding single point of contact as well. So if that table has been stuck, everything, your entire application has been closed. Okay, you can't use that. So to avoid such kind of problems, so try to normalize your data and try to divide, not to store your data in single table. Okay, try to put it in a different tables. Okay, small tables. Now what is a denormalization? So it's a just and reverse process of to the normalization. In normalization, we will be saving the things from one big table to the different small tables. But in normalization, we are doing it in a reverse manner. Means we are keeping all the we are combining all the small table data into a big single table. Okay, that is called an denormalization means. So yeah, now let's talk about the different types of normalization forms in DBMS. Okay, so what is a normalization? So basically a normalization is a process of organizing the data in database, okay, to avoid a data redundancy and some anomalies. So what is a data redundancy? So data redundancy means simply you can call it as a duplicates. Okay, so what is anomalies? Anomalies are problems, okay, that were arised during the uh, data insertion in a table or well, like in database. Okay, so let's see. So let me write the definition of that following. Okay, a normalization is a process of organizing the data in a database to avoid data redundancy, comma, anomalies. Okay, so this particular data redundancy means storing duplicates or means a duplicate values. Okay, anomalies means you can simply call them as a problems. So hope you still might be in a confusion. Let's see what does this. Okay, so let's take an example table. Okay, where you will be having employee ID, employee name, and employee address. Sorry, employee address. This is not address. This is let's consider this is a department, like where he belongs to. Okay, where he belongs to, and the department ID. Okay, department ID. Cool. So let's assume this is our database, and we do have some records in it. Okay, let's say when I say records, it might be, let's say, employee ID 101 and name is Vamsi. Okay, so employee department is let's say we do have department names like a Godavari. Okay, so and department ID, let's say department ID is a D101. Okay, D101, and we do have another record, let's say a Reddy Krishna, he belongs to Krishna department, and department ID goes something like this. Okay, now we do have another thing. So a Vamsi, sorry, a Vamsi, and he belongs to mm, Spider-Man's team or Avengers, whatever you may call. Okay, and also a Vamsi is like 101. This person is again belongs to another team. Let's say Krishna. Okay, he belongs to Krishna team also. Now let's see. Now let's see what are all the anomalies we might get. Okay, so first one, tell me. So let's assume here Vamsi is like 101, 101. Okay, now there is two records associated with 101 employee ID. Now I wanted to update the address of a Vamsi. Okay, I wanted to update the address of an update the address of 101 employee. Now how many times I need to update? Two times. Now let's suppose I forgot. Okay, I forgot to update for two times. I have updated only for one time. Okay, I have updated this guy. Okay, so I have made it as a Bangalore, and still he belongs to a Mumbai. Now tell me, is this a problem? This might be a problem, right? So this kind of problems is called as an update anomalies. Okay, update anomalies. Now let's discuss about a delete anomaly. A delete. Now let's say suppose I am trying to delete the department. Okay, so like we have an Spider-Man department with the department 103 ID. We are trying to remove that entire department, like means decompose that particular uh, department. Okay, now so if I delete this particular department, this entire record will get deleted. There might be a chances. So what is happening? We are losing one person. Do you think that? Yes. So that is called a delete anomaly. Okay. Now what is an insert anomaly? So let's say, so this particular department ID is a primary key. Okay, this is a primary key. Now I'm a new joinee. Okay, so I joined in a company 2 days back. So still I am in an training phase only. No department is being allocated for me. Okay. Now some people is trying to update my database to get an ID card for me. Okay. So now tell me, do I have department ID currently? And no, because I am not assigned to any department, right? So whatever the data I have is this particular employee ID, let's say 104, and a name, let's say Sai. Okay, so I don't have department employee department and the department ID as well. So it won't take the this record, right? You record these code, sorry, you record it won't take this particular record. So what happens? Okay, so it won't take that record, so we lost the one particular employee name. So that kind of problem is called as an insert anomaly. Okay, insert anomaly means during the insertions, like insertion into the a DB. So delete anomalies means while deleting the data from a DB. Update means while updating the data which is present in database. Okay. Now this is about normalization and anomalies. So how we are going to solve this kind of problems is called as an normalization. Okay. So we do have different types of normalizations. So those were or a classifications. Okay, you might call it as a classifications as well. So first one, 1NF, 2NF. So first normal form, first normal form, a second normal form, a 3NF and BCNF. And we do have a 4NF and 5NF, but this were not necessary. Okay, not necessary. What does it mean not necessary? So whenever we achieve this BCNF for a particular table in database, then we can say that there will be no data redundancy, there will be no anomalies. Okay, so we can say that that particular table is all set. Okay, so we don't require these things. Okay, so that is the reason why in interviews also, in most of the interviews, they don't track this 4NF and 5NF topics. Okay, they will end up at BCNF. Okay, not even BCNF. Yeah, so in some cases they will ask you BCNF, otherwise they will just ask you to define this what is 1NF, 2NF and 3NF. But when I say like when they ask you to define, it's your responsibility to take an one example and then you need to explain it, because in an interviews mostly interviewers are not interested in hearing the standard textbook definitions. They want something like more than definition, like let's say concept. Okay, what you have understood from that particular point. Okay, that is what they want. Okay, that is what they are expecting from you as well. Okay, now let's see what is 1NF. Okay, let's start with 1NF. Okay, let's say we have a table like this. uh, Student ID, student name, and student mobile number. Okay, student mobile number. So what is the data? It has a student ID is 101, 102, 103. Names are Vamsi, Reddy, Sai. Okay, so now mobile numbers are, this guy has a two mobile number. Okay, so I am writing only 5 digits. Okay, so consider in real case. Okay, so another thing, another mobile number is this, and this guy has this, and this guy has this. Okay, these are all the mobile numbers they are holding. Now tell me, so the formula of like what is the principality of 1NF is an attribute of a table cannot hold a multiple values. Okay, it should hold only atomic values. Atomic values in the sense it has to contain only one value under one particular attribute. Let's say, so in our case, under student mobile, we are holding a two values, right? So this is not the 1NF principle. So we need to convert this table into the 1NF, right? So we need to convert this table to the 1NF. So here what we can do now, we can simply flat this like entire table. So when I say flat, let's say what we can do now. Okay, so what we can do, let's say 101, 1C, 1, this one is 1, and I can make this 13425 with another new record. Okay, so same ID is same, student name is Vamsi, but mobile number is 13425. So now there is no problems in this 102 and 103. If suppose again 102 has
uh, two or three mobile numbers. Let's say three mobile numbers. Okay, three mobile numbers. Okay. So now again, this with this particular student ID, we might have a three records. Okay, in our flat end, in our 1NF converted table. Okay, so something like this. So here we will have first number. Here we do have a second number. Here we do have a third mobile number. Okay, so this is what first and first normal form. Okay, now let's talk about a second normal form. So let's first discuss the principles of second normal form. So here the principles are: first thing, a table must be in 1NF. Okay, so whatever. So whenever we are trying to convert one particular table into an 2NF, that table must be in a 1NF. Okay, it must has to satisfy that principality of 1NF. Then second thing is no non-prime attributes. So non-prime attributes in the sense non-primary key attributes. Okay, is dependent on the proper subset of candidate keys table. Candidate keys. Okay, let's see with one example. Okay, I'm sure by seeing these definitions you are not going to learn anything apart from mugging up those definitions. Let's see. Okay, now let's see. So we do have a table something like this. Okay, so a student ID, a student name, and a student age. Okay, so student ID is a 11. So let's say 11 triple one. It's not a student name. Let's consider it's an course. Okay, which a student has been enrolled. Okay, so 101 student ID is enrolled in, let's say, DBMS subject, and his age is 21. Now again, 101 student might be enrolled in other courses as well. So what is that course? It's a OS, like operating system. So again, his age is 21. So we do have another with a student without ID 120. Okay, so he is also enrolled in computer networks. His age is 22. Okay, now another guy with 120 sim, and he enrolled in an machine learning subject with age is 22. Okay, so this is the data we have in our table. Okay, now it's our job is to convert it into the 2NF. Okay, now let's say, can I say that this particular table is in 1NF? Yes. So for every attribute, it is containing only one value, so that I can say that it is in 1NF. Now we need to follow the second principle of this guy. Okay, so the here tell me, what are all the candidate keys here? Candidate keys, only student ID, right? So the keys which are helpful us to identify the record uniquely, that is only this student ID. So what we can say, what we can do, so here our primary key is, prime key is student ID. Okay, primary key is a student ID. Now what they are saying, so they are trying us to, every non-prime key attribute has to be dependent on primary key. That is what they are trying to say. Okay, let's say, so what we are trying, so can I say that this course is depend upon this particular student ID? So if I give you particular student ID, can I say all the courses that that he enrolled in particular semester? Yes, I can say that. Now tell me, if I give you particular student ID, can I say that? So can I get the age of that particular student? Yes, that might be the case. So it's your table has been simplified something like this. Okay, so let me draw here only. Okay, so what I'm trying to do now, so first I will have two different tables. One is a student age, age table. So where I will be having details of all the ages of a particular student ID. Okay, let's say here this guy triple one student ID with triple one having an age of 21. Okay, now again to triple one 21. Yes, we do have that. Now again 120 22 age. So 120 and 22 age. Again 120, 22 age. Now whenever I want age of particular student, okay, now I can simply give you the student ID. You will give me the you can give me the student age. That's okay, fine. Now what about this course table? So I will leave you that course as it is, because so if we wanted to make it as a, how can we make it? So you can make it like this, but we are violating the principality of 1NF. Hope you have remembered the definition of 2NF, right? So that table must be in a 1NF, and also that has to be in an like all the 9 non-prime key attributes must be associated with the prime key attribute. So I will leave that course table. I will leave that course table as it is. Okay, something. So let's say 111, 111, 120, 120. First guy is enrolled in DBMS, then OS, then CN, then ML. Okay, so whenever I want this particular student age, I will simply make a call to this guy. Okay, done. This is what 2NF. Okay, so it's very important to know the examples. Okay, at least if you are in an interview, you have to say these kind of things. Okay, so not even like simply drawing all the stuff. Even let's assume you can say something like this. Let's assume, sir, we have one table with the attributes like student ID, student name, and the student age. So here the principles of second 2NF is the table has to must be in 1NF, and it all the prime non-prime key attributes must be dependent on the primary key. Then you can divide those things into a multiple tables. That's it. Okay, now we'll talk about 3NF. 3NF. So what is this 3NF means? Let's say, so I can say that it has to be in table must be in 2NF. Okay, table must be in 2NF. That is for sure. Now apart from that, so there will like let's say transitive functional dependency of a non-prime attribute on any super key should be removed. Okay, so yep, it doesn't make sense to you. I will take one example and we'll see what it is actually. Okay, let's say we have a table of employee this time. Let's change the table this time. Okay, let's say employee. So employee ID, employee name, and employee address. Now let's consider address. Okay, so pin code. Okay, so pin code or zip code, whatever you might call. Okay, and then I am storing the state, then employee city, then employee district. Okay, so it has some data. Let's assume we have all the data. Now what I'm trying to say now, so this, if I give employee ID, I can get this entire row uniquely. Is there any key something like that? No. So here candidate key and primary key is employee ID. Employee ID. Now, is there any possibility of decomposing this table again? So think. Yes, I can say one thing. So now let's forget this entire table. Now let's assume we have this only table. You have this table. Now can I say that this, if I give this entire pin code or zip code, whatever it might be, so can I get the entire row in this particular table? In this particular table, yes, right. And the pin code and zip code, pin code or zip code is very unique. Okay, it must not be given to another state, like another districts or another places or another legislatives, right? So what I'm trying to say, so I will decompose that entire table into two tables. So I will have employee ID, employee name, and employee pin code. Okay, I will have something like this. Now I will make this pin code connected to another table called address table. Address table, where I will be storing all the pin codes. Okay, let's say I will have a pin code, then a state, then a city, then district. Okay. Now, whenever, so I will give all the pin codes here, particular employee. Now, whenever I search with this pin code, I will get a entire state and city and district details. That works. That works, right? So this is about the 3NF. Now, now we'll talk about the BCNF. Okay. Now we'll talk about the BCNF. So the full form for BCNF was voice a code a normal form. Okay, voice code normal form. So again, the conditions like our principles of this particular will be, so it has to be in a 3NF for sure. The table must be in 3NF. And a second thing, so like I can say that BCNF is a little stricter than a 3NF. Okay, so a table complies with BCNF if it is an in sorry if it is in 3NF, and for every functional dependency, okay, let's say x to y, x should be super key of a table. What does it mean? Let's say suppose let's take one example. There is a company where employees works in multiple departments. Okay, employees works in multiple departments. Let's see. So uh, employee ID, employee nationality, employee department, and department ID, department ID, and a number of people in department, particular department. Okay, now we'll see. So employee ID is 101, and employee nationality is Indian here. Department he works for Godavari. Department ID, let's say 101, and in particular Godavari there were 250 people were working, let's suppose. Okay, and you do have so again this 101 guy, so 1001 guy also works in another department. Let's say again he is an Indian, so he's another department is Krishna, department ID is 102, and in that particular department, let's say 100 people are there. And there is a guy with 100. Again, he works for two different departments, and his nationality is American. Again, he works in both Godavari, Krishna. 101, 102, 250, 100. So this is the table that we have. Okay. Now let's try to identify. Okay. So let's try to identify. So can I say that can I say this entire employee functionality is dependent on this, employee nationality is dependent on this employee ID? One thing. Yes. Now I can say that employee ID gives you employee nationality. Now, what is the other case? So, can I say that? Can I say that employee like these things? So, yeah, department ID and number of members in a particular department is dependent upon the this particular department. Yes, employee department. Yes. So, I can say that employee department is equal to employee department ID and a number of employees. Okay. Now how we are going to take this into the BCNF? Okay, so we can break this entire table into three tables. Okay, let's say how. So first table, let's say nationality table, nationality at table. So in that I do store employee ID and employee nationality. Okay, so 001 is an Indian, and this guy 1002 is an American. That's it for this particular table. Now I will have an another table. Okay, so where department table. Okay, department table. Let's say we'll have department ID, department people, like number of employees. Okay, so first department we do have Godavari, and ID is 1001, and number of people this. And then we do have a Krishna, and it is a 102, and we do have 100 employees in that. Okay, that's it. Now we'll have another a table which is currently mapping to that particular both tables, right? Let's say so now I will, in this particular table I will have only the primary things. Okay, primary keys, primary attributes. Let's say what is the primary attribute in a table one? It's an employee ID. Now what is the primary attribute in a second table? It's an employee department. So now I can say that 101 belongs to Godavari. Again 101 also belongs to Krishna, and 102 belongs to Godavari, and oh, this guy belongs to Krishna. Then so whenever I need entire department details, I will go to Krishna. I will get that. Whenever I need an nationality of a particular employee, I will go to nationality table and I will get the nationality. Okay, so that's all about normalization. Okay, so I highly recommend you to think on your own. Okay, like try to frame. Okay, take a couple of examples and try to divide those things, what kind of problems that you are going to get